Alright, you see I got a little head start on you here today. I filled in this whole chart, so at some point you're going to want to push pause on this and probably copy this chart down if you need to. Maybe you do, maybe you don't. So we're looking at all the different relationships here between sine, cosine, tangent, cosecant, secant, cotangent on the right triangle and on the unit circle. If you notice, I wrote those a little bit different there on there than we had the other day, because if you're not on the unit circle, you could still find those trig ratios if you know what the radius of that triangle is. All right, and I'll show you what I mean in just a little bit. So push pause sometime, copy this down. Now, as you come back and you are looking at this some more, it's really important that you know these relationships. Really important that you know how to find all 6 of those trig ratios. So we're going to spend really the bulk of the video right now just working on some example problems. And I'm going to give you different information. I'm going to give you various information and ask you to find all of the trig ratios. I just got to apologize already. My screen right now isn't working very well, so there might be some times that I either write really poorly or it just takes a while to write what I want to write. So the first kind of problem, I'm going to give you a point that lies on the terminal side of the angle. So remember how we define angles now? It's that rotated ray and where it ends up. And so if you know that there's a point at 4, -5, I want you to be able to find all of 6 trig ratios. If you think you can do it already, go ahead and do it. If not, then feel free to follow along. But like I said, at any point you want to push pause and try to figure it out, go ahead. So what I'm going to do, I'm going to build my triangle, and I'm always going to build my triangle with a side along the x-axis and then another side going to the point in question. Now I'm going right, so that's a +4. I'm going down, so that's a -5. At this point, I should be able to find my trig values really easily. I'm going to use Pythagorean theorem to find that third side. So 4 squared plus -5 squared is 16 plus 25, so that's 41. Take the square root, I get the square root of 41. That's my hypotenuse. So I have all 3 sides. So doing my trig ratio should be really easy. Make sure you get rid of the radical in the denominator. And again, if you struggle doing that, you probably need to come and talk to me so that I can help you with that. And so as I'm working through it right now, I'm just, we call it rationalizing the denominator, getting rid of the radical, taking your opposite now over your adjacent to find your tangent, doing your reciprocal functions should be pretty easy right now. Just flip those upside down to find cosecant and secant, and then ultimately cotangent as well. So this is one of the problems you got to be able to do. I give you a point on the terminal side, and then you give me all 6 trig values. Okay, trig ratios. Make sure you get a little practice of that in the homework tonight. Alright, next example. Now I'm going to give you one of the trig ratios. So I'm going to tell you that the tangent of the angle is -5/4. So my first question for you is that enough to figure out what the sine and what the secant of that angle would be? So think about that for a second. Do you have enough information right now to figure out those trig ratios? Well, if we try to graph that, where could we have -5/4 be the tangent? So if I draw my triangle over here in the 4th quadrant, I could have 4 for my adjacent side and -5 for my opposite side, and that would give me -5/4 for theta. Or I could put it over in the 2nd quadrant and have 5 for my opposite side and -4 for my adjacent side, and again, in both these cases the tangent of theta would be -5/4. So I need more information than that. That's not enough. I have 2 different possibilities in this problem, and that would affect what my answers are for those other trig values. So how about we give you kind of the same question here. So this time now, I'm going to tell you that the tangent of theta is still -5/4, but you also know that cosine is going to be less than 0. So I'm telling you that I have a negative cosine. I have a negative cosine. So think, if you could please, where would that have to put my triangle at? Would my triangle be down in that 4th quadrant, down there where the red triangle's at? Or would my triangle be up there in the 2nd quadrant where the blue triangle is at? Which one would give me a negative cosine? Again, I apologize for how my video is acting right now. So if I think about this, I really don't have to find the hypotenuse in these problems if I don't want to. But just so you can see, in each of these cases I do Pythagorean theorem, and 4 squared plus negative 5 squared gives me 41, and so the square root of 41 is my hypotenuse, and so there's a positive cosine value in the 4th quadrant. And over here, that's negative 4, that's my adjacent side, divided by the square root of 41, so there's a negative 1. So right there, it tells me, hey, that's the triangle I need to work with, the one in the 2nd quadrant. So now that I know that my theta is over there in quadrant 2, I should be able to go ahead and find my answers now. So for sine, remember, is just opposite over the hypotenuse. So the sine of theta is 5 over the square root of 41. And again, I need to rationalize that denominator. So when I multiply the top and the bottom by the square root of 41, my answer is going to end up being 5 radical 41 over 41. And then for secant, remember, secant's going to have my denominator, or my hypotenuse on top, and then my adjacent side on the bottom. Just the reciprocal of my cosine I found earlier. Alright, so again, look for some problems like these to do in your homework for practice. Alright, a couple of things. You might have picked up on this now. We're going to get a little bit of a different definition here, or a different idea of what reference angles are. So every single time that I'm given a problem right now, I'm building basically the same triangle in 4 different spots on the coordinate axes. So my reference angle is always going to be the acute angle that's formed by the terminal side of theta. Alright, so that's going to be anywhere. Alright, I could be sticking out in any of the quadrants. And the horizontal, or the x-axis. Alright, so no matter what theta I give you, no matter what information I give you in a problem, we're always going to build a triangle where we're using the x-axis as one of the sides of our right triangle, and then we're going to build the rest of it to that terminal side, wherever that might be. So I'll give you a couple examples here. Suppose I have a negative 100 degree angle. So if I rotate clockwise 100 degrees, it takes me down to about here. And so if I'm going to work with that angle, I'm going to build a triangle that looks like this. Okay, theta is actually going to end up being an 80 degree angle within that triangle. So I would say my reference angle for that is 80 degrees. And I could use all the trig information I know about 80 degree angles now to answer any questions I might have on the 6 trig ratios. What if I have a 118 degree angle? So now I'm going to rotate counterclockwise, so up and to the left 118 degrees. And then to figure out what my reference angle is, I'm going to build my right triangle now. I draw my terminal side. I'm going to use that side along the x-axis still, and my reference angle would be 180 minus 118, which would be 62 degrees. I can do the same thing with radians. Suppose that I want to work with 2 pi over 3. So 2 pi over 3 radians. And so I rotate that in a counterclockwise fashion again. 2 pi over 3 is up over here to the second quadrant. And again, I draw my right triangle from there now. So terminal side down to the x-axis and then over along the x-axis. And my reference angle for that is going to be pi over 3. How did I get that? Pi over 3 would be 1 pi, 180 degrees, minus 2 pi over 3. So reference angle. It's an important idea. We're going to use that a lot as we find all of these trig values. What I want you to do right now is I want you to push pause here in a second, and I want you to read through the chart that's down towards the bottom of page 594. I had a former student come back and talk to me at a football game the other night, telling me how important it was in his calculus class in college to know the information on the bottom of that page. Know it, like memorize it. Just know those angles, know those values. So go ahead and pause. I'll wait for you. Alright, you really got to make sure you commit that to your memory, what those values are for some of those angles, some of those thetas. Alright, so let's get back to what we've been doing here. We're going to find some more trig ratios right now. So I want to find the exact values now of the sine of an angle. We'll call that angle T. If we know that the cosine of the angle is 8 over 17, and we know that the angle is in quadrant 4. So I'm giving you 2 important pieces of information here. I'm telling you 2 of the sides of the triangle, and I'm telling you where to draw that triangle. Okay, so I build along my x-axis, I build down into quadrant 4. Now if I have cosine is 8 over 17, 8 would be my adjacent side, and 17 would be my hypotenuse. First thing I'm going to do now is Pythagorean theorem. Working through that, I'm going to figure out that x squared is 17 squared minus 8 squared. So that's 289 minus 64, which gives me 225. Take the square root of that, and my missing side is 15. Now that I have that side, I can find sine, and I can find any of my trig ratios. But remember, it's not 15 that I'm going to put on my triangle. Since that's dropping below the x-axis, remember, I'm going to put what? That's right, negative 15. And so now my sine of angle T is opposite, negative 15, over hypotenuse 17. You could do that trig ratio as well as all of the other 4 trig ratios if I ask for them. In fact, that's what I'm going to do now. In this final example, I'm going to give you some information and ask you to find all of the trig ratios. If you think you're up for it at this point, make sure you push pause, try to do what you can do before I just walk through the problem and give you the answers. So in this problem here, I'm going to tell you that the cosecant of my angle, come on, let's work here. Gonna apologize for this. The cosecant of my angle is negative 3. The cosecant is negative 3. And you know that the angle is in the 4th quadrant. So again, I'm telling you where to draw your triangle at right now. Sometimes I'll do that. Sometimes I'll just tell you what one of the other trig values, if it's positive or negative. And so you're going to have to figure out based on that where it might be. So right now you know that the cosecant is negative 3. And, oh, I'm sorry, we won't go quadrant 4, we'll go quadrant 3 this time. So x is in quadrant 3. Okay, so if you want to push pause right now before I do all this for you, go ahead. But go ahead and find the other trig ratios. Alright, so the first thing I'm going to do, I'm going to build my triangle. I'm going along the x-axis. I'm going down to the terminal side. And let me think here, cosecant is negative 3, so that means the opposite reciprocal. Not the opposite reciprocal, excuse me, just the reciprocal of that. Sine would be a negative 1/3, so opposite side is negative 1. Hypotenuse is 3. I'm going to do Pythagorean theorem here. Take negative 1 squared, add it to x squared equals 3 squared. Do my work. Take the square root of 8. Simplify that, I get 2 radical 2. That's my adjacent side. Now, I want you to notice that I've made a mistake now, so please correct this. That adjacent side, 2 radical 2, that should really be negative 2 radical 2. So my cosine should be negative 2 radical 2 over 3. My secant should be negative 3 radical 2 over 4. My tangent, since it's negative over negative, should really be a positive radical 2 over 4. Not negative, because it's negative divided by negative in this problem. And my cotangent should be a positive 2 radical 2. Make sure that you don't make those same mistakes I just made. Now, as I write the homework assignment down, it's up to you how much time you want to devote to this outside of class. I will give you time in class next time to practice some of these problems, but you know right now how well you understand what I've just done and how much time you need to practice this. So on page 596, I'm going to put right down here about a dozen or so problems. You make sure that you spend enough time to practice these so that when I give you the quiz over this material, you are sufficiently prepared. Alright? So be ready to ask questions, be ready to demonstrate that you understand how to find trig ratios given all of these different pieces or styles of information. Alright? Talk to you next time. Thanks.